Якщо всі методи можемо власне починати, я як представник Дмитру, як головний, буду радий дослухати ці історичні презентації, які я мав вчорашні, і слово трошки доповідати.
So, good morning. My name is Mishchenko, and I'd like to present results of my work on the topic advancing medical instrumentation with pseudo-labeling of public datasets. And I want to start from a short background. So, I'll talk about instrumentation. So, basically, it's the process of dividing an image into multiple segments to identify an object. And this example, we segmented different datasets by the colors to different classes. This is done by a labeling process, so it refers to the manual finding meaningful labels to image pixels. And important note that image segmentation usually means that we work with 2D images. However, if we talk about the medical image segmentation, it has some differences. So in this example, we have segmentations kidney, tumor, and cyst segmented with different colors. And what differences? So, medical instrumentation often involves working with 3D images such as CT scans or MRI scans. Second one is commonly focuses on segmentation of small objects such as tumors. And the last one, the evaluation of segmentation accuracy in medical segmentation might need to consider clinical relevance, because when we talk about medical segmentation, we talk about health of people. So, since medicine is a strictly regulated field, accessing medical data can be challenging due to its sensitive nature. And from this, we have a problem. It's lack of labeled data. So, we have a lot of public data sets that are unlabeled, but we have only a small amount of them are properly labeled. The most main strategy to acquire more labeled data is to ask people to segment it. However, high quality labeled data is expensive and time consuming because it requires manual work by experts. And the second one is make use of unlabeled data, which we propose in our work. So basically, we want to extend our training data set by pseudo-labeling of some part of unlabeled data and involve it into the training process. Hence, our main objective is to investigate the influence of integrating pseudo-labels into the training procedure on term segmentations. And our research questions are next. The first one, does pseudo-labeled data benefits performance of the model in the medical segmentation? And second one, how does incorporation of different unlabeled datasets affect the performance of the models? We use different data sets. The first one is KIDS21. This data set contains 300 CT scans for kidney, tumor, and cyst were manually segmented. This data set has a pretty large number of high-quality images and it provides a reliable benchmark for future conversion. Second one is SPID17 data set. This data set contains 131 CT scans that cover diverse types of liver tumor disease. Originally, it was designed for the liver tumor segmentations, but we can use it in our work. The third one is the depletion dataset. This dataset contains over 10,000 studies from 4,427 unique patients. However, not always studies are relevant to us. So we mainly work on kidney segmentation. So if we pick only appropriate cases, we get only 344 cases. Depletion also does not have ground truth labels. However, it has key slices with bulging boxes in there. About training framework, we propose to use semi-supervised approach to generate pseudo-labels. It starts from the training fully supervised model. It's a teacher model with the KIDS21 dataset. Since we have ground truth labels and we can properly do it. So the second step is to generate pseudo-labels for the 17 and depletion dataset. After that, we can combine this into one large dataset and repeat the procedure of model training with the student model. About model architecture, for the model training, we used the EnergyNet framework. Basically, EnergyNet is an ensemble of 5 models for folds. Each fold have its unique train validation data split, and it work under and subdivided into one model. So our experiments are next. I remind that we work with kidney system tumor segmentation. So the first one is naive training. We use KISS21, and the first configuration mainly used to train the teacher model. The training process basically involves feeding the model with scatter scans, and it learns to extract relevant features and segment through mid-system tumors. Second one is experiment with the LEAD17 dataset. We utilize the pre-trained on the KISS21 dataset teacher model to generate pseudo-labels for the LEAD17, and we merge it with the KISS21 and repeat training process with the student model. Experiment with the depletion basically is the same as with LEAD17, except at this particular case, so we can compare results of teacher model prediction with the key slices, and we can understand if our generated pseudo-labels can be used generally for model training. The last experiment of semi-supervised approaches with combined dataset. As I said, we merge all dataset into one large group and repeat the training process. By integrating data from the different sources, the model can potentially benefit from more extended range of data and different types of patients. And the last experiment is transfer learning experiment. The main goal of this experiment is to provide an additional baseline to compare our proposed approach. This experiment employs a simple transfer learning approach of fine-tuning model from one domain with weight from another. In our case, we trained the segmentation model with its dataset and then transferred the weights to the kidney segmentation model, which was trained on KISS21 dataset. To measure performance of our model, we use the DICE score, which is commonly used in medical image segmentation task as evaluation metric. It measures the similarity between the predicted segmentation mark and the ground truth segmentation mark by computing the area of overlap to the total area. We use 2 types of DICE coefficient, the regular DICE for the 2D images and the circular DICE for 3D surfaces. And here are results. It's average DICE scores for all segmentations. We can see that the teacher model outperformed other models in terms of average DICE scores. However, we can see the transfer learning experiment achieves best results in terms of surface DICE. And we see that LEAD17, this experiment with the LEAD17 achieved second best result in average DICE. And we can see that depletion, experiments with depletion combined dataset lag behind other experiments. This potentially could be due to data quality. If we check the average surface DICE scores, they are almost the same as the DICE pictures, nearly the same. However, we can see that experiments with the LEAD17 also lag behind. So our approach had difficulties with the capturing the surface context. Since our main goal is to check how our approach works under the tumor for the tumor segmentation, we want to let it separately, and we see that experiments with the LEAD17 achieved best results. However, improvement is not substantial, and we also again see that the teacher model yields the second best scores. By looking at visual results, we see that we have the different cases with prediction from the different models. So green is kidney, yellow tumor exists again. We see that certain models with various data combination yield different outcomes. Some models started to see tumor in different places, such as the bottom row. We see that teacher and the vision model have segmented tumor on the liver. So to confirm that our approach work stable, we decided to perform additional series of experiments. But due to data limitations, testing our approach on different data sets is not possible. So we decided to have to perform experiment and see how our approach works in a low data training regime. So we conducted a custom split on the KIDS 21 dataset. We separated it 300 cases to 250 for the trained data and 50 for the test data, and repeat our experiments. So we decided to work only with lead 17 since the division achieved worse results in previous experiments, but we added one more experiment. Basically, we want to check if transfer weights from the teacher model to the student model would be beneficial overall and compare it to the naive extending of the data. Here are our results. We see that the teacher model again leading in almost all categories. However, we see that our second experiment with transfer learning weights teacher model to student model have better results overall than the simple extending of data. So it's a valuable achievement. Exploring the visual results with low data, we see that model predictions, we have more similar shapes of predictions. Another series of experiments that we conducted, we wanted to access the scalability of our method across various types of segmentations. So we decided to choose the liver segmentations because we already used the lead 17 dataset. And we decided to perform additional series of experiments with lead 17 and KIDS 21. So basically, we repeat the whole process. We train the model with lead 17 and then generate pseudo-labels for the KIDS 21. And so here are results. For this experiments, we have only two metrics. It's liver dice and vision dice. Because model can predict only liver's division. We see that the teacher repeats the KIDS 21. Especially in terms of vision dice. This problem arises from may arise from the data we used because KIDS 21 dataset was designed for the kidney segmentation, so it might not have livers on its scans. And visual results of student model are also poor compared to the teacher model. So our work contribution are next. The first one, we reviewed semi-supervised approaches in medical segmentation field. The second one, we analyzed 3 datasets in their application. And the last one, we explored the impact of involving pseudo-labeled public datasets in the training process. Our conclusions are next. Pseudo-labeled data have a mixed effect on the segmentation. On the segmentation model performance. So in some cases, when data is the quality of data is good, it enhances performance, but it needs to be better in our opinion. And the second one, different data sources for pseudo-labeling have different effects on the model performance, and naive extending on the training dataset is not always beneficial, as we saw. For further work, we decided to focus on the 2 ways. The first one is a more in-depth exploration into how image characteristics affect model performance. By the image characteristic, I mean resolution and other. And the second one is improved model training framework by training the quality of pseudo-labels based on the confidence level. We saw similar works for the 2D images and generally speaking, this type of improvement may be also be beneficial for the medical image segmentation. And that's all for this. Thank you. It's Q&A.
Right. I'm a little bit concerned about the sizes of the data sets used. Are those data sets big enough to behave robustly in the training process?
Yeah.
Are they representative enough?
Yeah. There's a general number of cases, for example, in case 21, so it's only 300. However, since medical image segmentation, we work with 3D images. So each case contains from 50 to 100 slices, separate slices, 3D images. And usually it's more than enough for the model training.
I can tell it's a little bit because the 300 slices are of the same organ, same kidney.
It's not the same.
It's not the same size.
Yeah, it's not
the same kidney.
Yeah, it's the same kidney.
This is why I'm about representativeness.
Yeah. So if we talk about the case 21 set, it was conducted from different patients that received the partial full kidney removal in the last 10 years. So all these 300 cases were stemmed not on one patient, so different patients that received partial kidney removal.
Didn't take any assessment of the representativity of the data. You prove that they are sufficiently representative.
Yes, we took the case 21 because the study used for the challenges in the segmentation level, and they,
this is not the point for being surprised. This is not the proof. This is just repeating what the other people say.
Yeah, but we base our work. So we base our work on that. We rely on their work in our work. So we just want to. Since I'm not medical expert, I cannot check the data set is presented. I cannot access the data about the patient, their sex, their age. So I do not have this data. I can only rely on the people that conducted the site do it properly.
There are all methods that allow to assess the representativity of the data set in terms of footprint on the topic on the today. Okay. What is the majority of those tags?
Yeah, it's this slide. Yeah.
So could I please say popular or majority votes?
Yeah. So basically, for each first slide, for each case, different experts, different doctors, they segmented the image. The majority vote is basically when we take all the votes and we, but by the majority vote, we select only region of overlap of the agreement, and then we use the region to relate our score.
So it's the prevailing sentiment of human value.
Yeah.
Okay. You mentioned that you decided to do the segmentation because there was data. Wasn't it too much opportunistic? To think this motivation is.
We decided to conduct additional experiments to test our approach to different organ types. We decided to do it with liver because we're already familiar with this data set. We didn't need to perform additional work. We we use it, this that would be good for this task.
So my problem is that the motive is guided by the available resource, which is opportunistic, isn't it? I mean, overall, only in that case.
Yeah.
So for all the cases where we have to train the model,
Yeah, I understand. I would disagree.
that's not that policy in the field.
I would disagree because we want to check on the controller, and it happened we already have this data set. So I guess it's delicate.
One formal question, the last one, sorry. Is a literature review a contribution to a research work?
I guess it's not a contribution. It's kind of we wanted to find some fields of information that was not covered before, and we just wanted to find our we wanted to find place for our work.
So at the end of the day, it was a contribution. You found the niche, you found the gap.
Yeah.
Did it? Okay. Thank you. I'm done.
Yeah, last question. As I understand, dice matrix is the zero when you have false positive or false negative.
Yeah.
And what is the can you estimate percentage of false positives and false negatives while you are operating?
So we didn't conduct it for positive and false negatives separately because that already includes them inside. So we wanted to focus on one metric, which would present.
What is the size of your training testing data set?
So for the first question, the bifurcated bit was 100. So it's separated a set from specific one. It was not involved in the training process and was delayed.
So, I mean, if you have 0.8 or 0.9 matrix, it means that less than 10% are all negative positive and all other are perfectly one.
Yeah.
It seems like unfeasible.
Okay, I got it. If, for example, I have a segmentation that not perfectly aligns, so it's average score. Yeah. So, for example, for some cases it might be 0.9, for some cases it could be 0.1, and we aggregate and calculate the average score for all cases. So it's not like for 90 cases it's perfect 1, and for 10 it's 0.
It's less for segmentation, not for classification.
Yeah. I mean, it's a overlap in areas, but 0.9 means that it's very good. It's almost perfect, and that's why
The overlap is 90%, which is, I support it.
So,
Really,
yeah, so we just so since we use an engineer, it's basically for additional chain, and the first one chain is one of the solve in this area. So
can you show me the result? I mean, even if you do not calculate areas, when you have no image.
images,
Yeah, like this. And I see that, well, they are quite, sometimes they're quite different in area.
I deliberately choose the most extreme cases when we have or big improvement or vice versa. So I mean, in this case, we see that
this last one.
Yeah.
Round 2 means that there are no tumor liver.
There's no tumor.
So it's all positive.
Yeah, it's all positive for the teacher and imaging data set.
Okay, but when you aggregate, maybe you just deliberately choose best result. So if you apply a majority vote here, you will have no, or you have like split. I don't know how you decide in this case the result. You have different
majority is 50%.
Yeah, but it's half. 50-50, in this case.
It's required.
So
And majority is pretty dangerous. Especially in medicine. It's not how I was asking about the majority.
Yeah, and as I said before, in terms of medicine, even 0.9 might be not the best results. We want more. So, yeah, and it was our main goal to.
Yeah, but, well, our concern question is that if you have so small data set, you know about no freelance theorem. So you can get very good result. You can get very good result if you don't have enough.
Yeah, so it was what our main contribution. So we wanted to extend it, say, by segregating additional data. So we wanted to check if extending the set in a way of segregating would be.
But having a small data set does not allow you to evaluate if
Yeah, but
it is valid or not.
yeah, but as I said, it's not a small data set. It's enough for the chain of
Yeah.
supervised network.
What is the exact amount of images you train for? Okay, let's say like this. I mean, that you take, because you said it's 10,000 studies, but we take only 300 because.
Yeah, so it's 340 bits in one, 161 from segmentation, also 40 bits in team, and okay. Yeah, and certain 344. So
Cases. So not take case, because everything in terms of images. So it's limited, one case, one image.
no, it's as I said before, it's strictly splitting. So we have different amount of slides. For example, from legs to the head, sometimes it's more.
So if you can give me the exact amount of images.
Yeah, I'm going to that. So not all images incorporate, for example, things. Yeah, if we take image from this part of the body, it does not incorporate.
Yeah, I understand. I just want to understand the size of training data set.
Would it include then resplitting the training if there is no kidney?
On the upper say remove the data process. So we crop our general, we crop each image and we choose only the meaningful images to us.
But again, so do you have images in your training data set where is no kidney?
Which one exactly training data set? Which
Data set
training for? Yeah, I mean, the truth is, if we're talking about data set with incorporation of several labels, it might, in some cases, it might not have any labels at all because there were
no labels. Are there images with no kidney?
So again, they would be in the training data set, but we work with the 3D segmentations, so it wouldn't be relevant.
There's questions. Because let me challenge your approach. You mentioned that the most problem is absence of many qualitative data.
Yeah.
And now you propose to make pseudo-labels, the data augmentation. How can you compare the quality of truly labeled data with this pseudo data and then train our model on this like data of unknown quality?
So we saw different studies on the 2D images that involved pseudo-labeling of data in terms of they have data sets, they split it, for example, on different pieces, for example, 20, 50, 60, or 100% were labeled, and other part were pseudo-labeled. And they, these studies come up with the idea that, conclusion that this approach wouldn't overcome in terms of result if all data was labeled correctly, if all data were labeled by the expert. On the other hand, since we do not want to involve experts in the training into the labeling process because it's expensive and very slow, we wanted to a bit faster to support this.
Understand, but it comes to the next question about overfitting.
But what's
Overfitting, if you have very low field data and you achieve better results, as for me, it shows that this model is overfitted with no goal.
Yeah, so it was our concern because if we use only a small amount of data for the training process, even if we use segmentation for this data and extend somehow the data set, it could lead to the overfitting. So this solution proposed a way to avoid it by extending the data set, so we have more data, more different patients. With our we were hoped that if results are good enough, so we can extend it on different data that were not, for example, collected in one place, maybe different places from the different machines or humans.
But have you tried your model on some other data? Beside of these data sets you use to train? Have you tried on some real images, on some images outside of your school data?
Nope. Nope. Unfortunately, no.
And if you deny overfitting, how you can include the key findings that gives you these benefits?
Yeah, so
was it like a combination of data set or some other things?
So if we come back to the tumor dice course, you see that combination with the lead data set achieve better results in the tissue model. Yeah. So we see that in some cases, efficiently, this approach benefits in more performance. But we see that, for example, there is lag behind.
But I mean, what do you think? What your key findings is to get better results?
So first of all, we need good data.
What was your discovery? What was?
Yeah. So we might achieve better result if we have good data for the training. If it was picked for this test respectively, even if it doesn't have the possible, even if it doesn't have the ground truth labels, we can use it. It should have good contrast, good resolution of image, and good power of image, I guess. So data set should be diverse enough for these different types of segmentations and good enough in terms of quality.
You can define what pseudo-label is.
Yeah, I forgot to mention about that. So pseudo-labels, yeah, so basically pseudo-labels is the output prediction as a teacher model.
What do you predict?
We predict segmentation, for example, for kidney
Segmentation mask or
segmentation mask, yes.
mask.
For the kidney image, it's each separate size.
When you mentioned that we work in needy objects, but actually you don't use 3D structure at all.
I didn't show them in my presentation because it's very hard to understand visual results like rotating and so on. It's pretty hard to understand what's going on. And furthermore, if we use the reconstruction of these images, they might have some difficulties with visibility because
But you don't use 3D structure and you don't produce 3D structure with your models.
You just feed the slices.
yeah,
Separate images.
yeah. But we can reconstruct it.
Yeah, you can, but you do not do this.
That's not part of your pipeline, your structure. You don't use no way. You don't use this 3D structure.
I got what you mean. So basically, an engineer during the training, an engineer involves. So it doesn't work with each separate slice. Yeah, it have modes where it can be used for like only images, but generally it works with the whole slice at one time. So it
Maybe both. So
it's whole case.
Then what you said about augmentation doesn't make any sense because you anyway have just 300 cases. If you fit the whole pack into your network, you don't have 20 or as many images. You still have just one case, so it's not back to the first question.
Yeah.
And so that's not augmentation. You don't increase the size of your data set.
And how do you feed the case? So we have a bunch of slices feed into network, and then another case, like one by one. How the model knows that new case arrives.
Yeah, so we have different bunches. So it works with bunch of images at one time and it processes them together. And as I mentioned on this slide, each fold of the model works with its separate training validation set. So it's like perform training on each step of the train, all train data, and validate it and the next step.
My next question is, you mentioned surface guys but I'm really puzzled. What is the purpose of these methods? Because what does the intersection of the surface rather than the objects give? If there is void intersection and for instance the return map is strictly inside the tumor cells, the tumor area. For that score, it's very bad situation, but in fact, the main purpose is not probably to ideally segment the tumor, but rather to help the experts to validate that the detected tumor was so this detection was correct.
I don't think so.
They just restrict attention to the segmented area to validate, not to look in the whole image, but just to concentrate the attention. So what was the purpose of this purpose?
I start from the validation point. So basically, medical image segmentation not only machine learning images. It not focuses on the validating results of the human expert. So we want to be at least as good as the human expert
and provide reliable results for the, for example, regulatory plan. When each millimeter is very important when you segment the tumor. Back to the surface size, we conducted two separate metrics. As I said, we dive more for the pixels and for each slide. When the surface more about the general structure of the tumor. So it works with what?
But you don't use voxel.
What do you mean by this?
You said that you fit slices, so it's 2D scans. That was my previous question. Is 3D models, are they used in the pipeline? So
Yeah,
you said that
we use
each slide,
based on this slide.
yeah, but these are still slides, and this is not somehow.
There is implicitly there voxels out there, but explicitly you do not.
Yeah.
So how you can start at 95%?
Actually, we didn't achieve 95%.
Okay, close to.
Yeah.
But still, my main concern is that if you have zero or almost zero this score, it doesn't mean that the segmentation is bad just because if you move 1 pixel below or above the true, and also what does it mean true? You see, even the expert cannot say if this border should be counted as tumor or not. So for me, it doesn't make any sense.
Experts do not validate a pixel level.
Yeah.
Maybe you don't understand surface as you understand. Can you maybe draw on this screen example of overlapping the images and how you decide what the part of surface is intersecting and how to calculate the surface flow?
Yeah. So if we have, for example, separate slices.
Okay.
I can get another slide. Yeah, this one. So we have separate images, slide for our count. For example, here we have our segmentation. Here we have our segmentation. Some sort of shape. So basically, we can just find that this part, this part, and this part would be this surface. So if we reconstruct it here, we get approximately something like this. So this kind of shape.
And what is the target and prediction surface you compare?
Sorry, can you?
Yeah, you in surface dice formula you have target and prediction surface.
Yeah. Yeah, it's notation for the we work with the surface in terms of surface dice.
So doesn't mean in your particular case. What is target? Is it the ground truth?
No, it's not the ground truth. It's
Well, prediction is the output of the model.
yeah,
And yes.
it's yeah, so it's basically the size of the website. So we here, yeah. So the third is the like area of the overlap, yeah. And when we say about the 3D presentation, it's more not 2D, but it's 3D. I hope I explained.
So we use 3D in the work.
Because here, as far as I can, use slides and use it not for separate image display, but for the whole one thing.
For the record structure. 3D image.
No, that's perfect, but you need, then you need the whole case go to trains. Yeah. That's what I asked.
Okay, maybe.
But you have case, you have case in class, in last data set or in all data set. In first data set, you have cases for separate images.
All data sets contain cases.
Oh, because you said that first data set contains 300 images and it should be really 300 cases. That is count.
I think 300%.
CT.
But you didn't mention that every scan is like.
Yeah, that was misunderstood.
Yeah,
Because the 3 scan is like one scan. Okay, one.
yeah, but it contains several.
I think that it should be on the slide.
Yes.
That
is why I asked you to have a preliminary presentation.
That's why I told you, please make backup slides. That you did. Okay, may I ask my last question? Is it return back to the table with the results? Which are still
I hope
excellent.
yeah,
This way. Are those results good or bad compared to what?
so we,
Because it says nothing.
yeah, I agree with the point. So we compare our approach with 2 models. In this case, the teacher model as full supervised model, and the transfer learning experiment as additional metric. So basically, we compare 3 different combination of data with our approach to fully supervised approach and transfer approach. And
What's the result of this comparison?
yeah, we hope to get that our method will outperform the teacher model. However, we see that it's not always happening. For example, if we were to the segmentation, we would outperform it, but not in all sections.
Yes, the teacher model is the full supervised model. Okay. That's what it is. Thank you. I'm done. Yeah.
Thank you. Dmytro? Please start when you're ready.
Good morning. My name is Dmytro Ivashchenko, and today I would like to present you a project on topic audio spoofing detection, which I was working on with my supervisor. Nowadays, generative models are really fast, really rapid, and many new models are made nowadays, and thus many unknown algorithms of spoofing are discovered, and we should have some countermeasures to protect ourselves from some fraud activities, from some phishing of organization or individuals. and thus we need some cheap and effective tool to actually separate between the spoofed and the genuine speech in real world scenarios. And audio spoofing detection solves the audio classification subtask, and our main goal is to build a system which detects whether the speech was spoofed or not. It may be spoofed with some voice conversion systems, some vocoders, some filters, or maybe with some deep generative models, for example, with concatenation of different chunks of audio. And this system should be robust to new algorithms, to new approaches to spoofing. And this process can be divided into three main steps. The first is preprocessing step, and it proposes the audio. The second is some feature extraction, and the third is the classification itself. When we talk about the signal preprocessing, the first thing that we should do is to frame the signal, because as you can see, it is the amplitude of some signal, and here you can see that there is a really different amplitude on different time steps of the signal. So we need to divide the signal into some small frames before the further analysis. But when we cut this signal into frames, we have some effects which we want to exclude. So we apply some specific functions, and that goes to a windowing process when we apply some windows to smooth the signal on the edges after they're cut in these chunks. And then we can calculate some feature representation, for example, for box spectrum. And when we talk about different representations, they mostly refer to spectrograms, which is the two-dimensional time by frequency representation, and the intensity of color means the amplitude of the frequency. And for the classification task, before the deep learning era, the classical statistical approaches were primarily used. For example, Gaussian mixture models or support vector machines. So you just comparing different distributions of spoof and genuine speech. And nowadays we often use just deep learning classifiers, and the ResNet models, ICNN models are widely used in the spoof detection. So they are the primary chose for the researchers, and that could be also used in different tasks for video spoofing detection, for example, or others. Their recommended performance is relatively high. Also, when we are talking about audio data and spoof data, we should keep in mind that the new algorithms are developed. So in real world problems, we usually do not have too much labeled data. So we have too much unlabeled data, and we want to use it. And we can use a semi-supervised approach to the models, to the frameworks. So train the model using this unlabeled data, this unlabeled audio chunks. The research questions of the project are how to deal with the lack of this labeled data in real-world application, and how to increase inference speed and make it as close as we can to the real-time process. And we thought that semi-supervised approach will increase this classification quality. And some loss functions shows for the classificator model will not affect too much on the inference speed, but will increase the classification quality. We use the data from the spoof 2019 competition for this project. It has two different scenarios related to the logical access and physical access, and it has data from different speakers divided, and it is divided into three parts: train, development, and evaluation. The train and development part contains one algorithms, and evaluation part contains different algorithms which are not included in the first two parts. Spoofing algorithms. So that means that we should make our system good for classification on known algorithms. So this split is made to make sure that we made our system properly. In our work, we also used capstral representations of the audio. So we used four different capstral characteristics: linear frequency capstral coefficients, null-frequency capstral coefficients, inverse null-frequency capstral coefficients, and constant Q capstral coefficients. And that were used for unsupervised training. The proposed approach can be described in the following way. On the first stage, we have some raw audio, and then it is passed through the encoder, and then we have some embedding, which we put to the classifier, and classifier whether the speech was genuine and spoofed. For the encoder, we proposed a scheme based on self-supervised audio detection scheme encoder, but with some changes to make it faster and less complex. So we replaced some convolutional blocks with some residual blocks to improve the training process and to make the faster convergence and the inference. And on the right corner of the slide, we can see the scheme of this residual block, and also we replaced the original scheme of unsupervised training. So we excluded some binary tasks which include some labeled information. So for that purpose, we only train the encoder during the unsupervised training on capstral characteristics. We use the following metrics for the analysis. The first is average mean squared error between these capstral representations and the representations which we can compute from the embedding. The second is the metric for classifier is equal error rate. It is often used in the spoof classification tasks. It is the error rate when we have the same or the closest false acceptance rate and false rejection rate. And the third, we also looked on inference speed on the evaluation. Our experiment starts with the experiments with the encoder. So we trained it not supervised on the training set and evaluated on the development set. We calculated the average mean squared error. And the first experiment was for the number of input channels, and we can see the more complex model gets the best results. But the difference of different other input channels, the difference between result is not high. Also, we tried different temporal convolution network architecture, which would possibly capture some temporal dependencies in our data. And actually, we see that there is two different basic models for it to make our results more reliable. And we can see that this architecture doesn't change too much, but less than the number of input channels. Also, we tried different numbers of residual blocks in the scheme of encoder. And we can see that the model itself is slightly better with 4 residual blocks, but it's not beneficial to use 4. And the last is the convolutional kernel of the residual blocks. And there we can see that the same pattern repeats for 2 basic models, that the smaller, not the biggest and not the smallest kernel size gets the best result. For the classifying experiments, we took the 3 encoders from the 3 pretend encoders from the previous experiment. The first for the different number of input channels. The first is the best model for 32 input channels. The second is for 16 and the third for 8. And we tried different loss functions for our LCN classifier, and we can see that the softmax activation function with a different LCN embedding size gives search results on development. Also, we compared it to other loss functions like OC softmax. So we can see that for different margins, the best model, the best result we'll get was the result for the second encoder with 16 input channels. The same pattern with AM softmax, which is editing margin softmax. This also was tested for different margins and different encoders. And we can see that it is significantly less than the original softmax, and that is in the for the model with the not with the middle complexity, we get the best results again. The last step was to make the evaluation of the results of the evaluation split. And there we see that again the second encoder gets the best result with the additive margin softmax or loss function. But there is a drop there is a broken equal error rate score. Also, we can see that all the models are performing relatively fast, and the inference speed is really really good for this task for the classification the 5-second channel. Also, I would like to mention that the pattern of the encoder is kept even after the training, after the classifier fine-tuning on it, and that means that this feature representations are probably useful for the purposes of the speech classification. The last thing I want to mention, the last thing I want to say is that the experiments show that applying the appropriate architecture for the encoder is really opposite for the good classification, but it can contribute to the result. There are more complex models which were used get the best results, so it's really a crucial task. The second is the introduced loss functions really affect and increase the classification quality relative to the softmax scenario. So, but the speed keeps relatively fast. Inference speed keeps relatively fast, and also there is a drop in performance that can be explained by some overfitting in development, because there were some repetitive experiments, and we can just choose not the best parameters for the model. And for the future work, thus we should consider maybe some other two-dimensional signal representations, some better hyperparameter optimization, especially for some temporal dependencies. Actually, do some modifications to live convolutional neural network, and to use some extra data sources, because in this data set includes just old algorithms, and to work in real world we need to use different data, which includes some modern algorithms. Thank you for your attention.
Let's start with setting definitions. What is a spoofed stage? Is just filtering spoofing or not, or shifting the frequencies? But different recording devices can have different physical characteristics, and the same original speech sound can be recorded in different way by different devices. So they are identical, they are not spoofed. Yeah, but they are represented differently in digital way.
We will connect to the specific speaker. We just want to make to capture some features from the signal to understand that that's spoofed or not, that is modified or not.
But the recording is automatically filtering some frequencies, and recording on different devices does this differently. So if you compare one recording and the second recording, the first and the second, they are different, but they are just the same recording of the same regional surface, the same. Yes.
So that's referring to the system characteristics, which we are using for signal once again. This system doesn't fit to every voice
voice recognition system.
Not voice recognition, but not to every voice recording. So that most the records to the data which we use for our system and which we want to use in real world application. So when we know the characteristic of the device we want to use for the audio, we can tune it to it and use the data for that approach.
But if you are given some recordings and you don't know the characteristics of the device which was recorded on, because you are doing for analysis, you are doing some set of recordings. How can you use them?
So for specific tasks, you can measure. I think for this stuff, we use the dimension
Can you be specific about this matrix ER? So
Yeah.
how do you interpret it?
For example, so that's the error rate, but with specific threshold. This specific threshold refers to the point where the false acceptance of full speech, false rejection of the bona fide speech is equal or as much false as we have in the text.
Do you have a specific formula for this?
It's pretty much.
Because I don't find it in your thesis.
There is a formula, so you can compare it, for example, theoretically with false acceptance rate plus false rejection rate. Yeah. And on the threshold, which gives the minimal difference between this false acceptance and false rejection.
Calculate the presentation.
So we can see that with almost equal cost, when that's loaded, we have the equal cost for the rejection and acceptance. We will false acceptance and false rejection. We can have the error of 5%, for example,
So it's better to have over.
Yeah.
But your reviewer, he mentioned best evaluation ER is
evaluations.
previous
Further that will develop that was the ER. And the evaluation set and imagine part of the lowest ER on the evaluation set.
Can you get back to my previous? Okay, what about real-time scenarios? So can you inference speed? So can you show us inference speed?
Yes, first, the last column in the evaluation, that's the average execution time on the evaluation set, and it is measured in milliseconds. And when we have a signal length of 5 seconds, then we have a small amount of time for milliseconds. For specification, it is obvious that it is working in neural networks.
But what do you mean in real time? So right now we have this translation broadcasting, right? And you need the whole bunch of let's say this sound recorded, feed it into network, or you can run it.
We are sequentially feeding the chunks for 5 seconds. For example, we set something for 5 seconds, it can be written by 5 seconds, 5 seconds, 15.
So you by design you pick 5 seconds. Why not?
Actually, that's for better capturing more patterns signal. It usually can be 2 seconds or 3 seconds. And it's 5 to,
So let's say we try, so we have this broadcasting streaming on YouTube, and people want to understand whether it's good audio right now or not. And then you have these chunks, whether I need to like slice the recording on those chunks, which goes like 1 by 1, or do I need to use it like a window, for instance, in convolutional networks, when I move the window and starting first, second, and so on.
with this different speed, we can consider Windows scenario when it has some offsets, for example. And some Windows size is 20 megabytes per second. And we can move this window and classify
Okay, thank you.
And as I understand, the state of art for this EDR is about 1%.
Yeah.
Yeah, and you have 12.
Mhm.
Yeah, so it's like very
Mhm.
decent. And second, you had a mid eval here on previous slide. What does it mean for? It's like best, so the real is like bigger.
The first question about art. So our goal was just to make the system good on inference, so we should have good inference speed, but also have some at least not bad specification quality of the volume, so it should be reliable. Actually, we do not beat this 1%, and we couldn't beat this 1%. We learned from other baseline, which used to their similar standard approaching, and it's still high. There was about 7% on the relation set. But that was the trade-off between the inference speed and the quality. So we moved on quality, but we made the model far less complex.
But we do not actually know the speed of the data format.
We do not actually know, but we can say that the model is a lot more complex and overall complex. And also it is can be used in scenarios of availability. One.
So, but me,
Let me do one. That's just
Was it probably me, not me?
no, it's just just new.
Minimum?
It can be minimal, but it shouldn't be there. So it's just development. Yeah. After the training.
Without me, should be first time.
So,
It should grow out.
yeah.
replacing marks.
Why must?
Yeah.
This very like topical work, of course, and also very applicative, practical. So I would expect, of course, like some kind of then you have some application which you would demonstrate for now.
Actually, no.
Just theoretical part.
Yeah.
How we could check like result in real life.
It is possible to protect the state
My question is about a kind of adversarial attack. Would the background noise like change the results, the prediction? So I speak now, and next some background noise added to my speech, and would it like change the result that it is spoken about? It is still me, and still I'm speaking.
For me, I do not research on much, but it actually may have some impacts.
I guess for me it's very obvious.
Yeah,
Very
yeah.
obvious, like yeah.
So for that reason, we use different representations, engineering representations, to train specifying the low rate horizontal and the lower level representations. So we took only higher characteristics.
So you tried all the things, one the consistent data set you mentioned in your work, and that's all, not real life examples.
Too small again, there are only 100 persons, so
There are not 100%, but there are like samples in it. There are
but still those are the same persons.
the same person, but you should, but actually, there's only 4 or 5 examples, and then you can do some work, do some conversion algorithms, use some speech algorithms, and represent the speech in.
So you can make your spoofing data set as large as possible, but again, it would be made of these original recordings of those 100 people. So again, it is very specific to this data set.
And this group of subjects.
Yeah. And do you remember the question I asked you on the master symposium? If we record speech and then play it and record again, how would it be classified as a spoof or not?
Again, I don't consider this scenario.
But then you have 3 months. Consider
That was
the intention of the question.
but I would say that it shouldn't affect because of the high characteristics of all the thus it should be robust.
Depends on the quality factors they use for recording.
Am I right to understand that you need, sorry, but there was no like scheme which like clarifies this question. So am I right to understand that your algorithm doesn't need a kind of previous speech examples to identify its spoof or not? So it works from track with no previous data.
Not so. First of all, you have this the hot stage encoder stage when you can put the characteristics of available data and make this encoder as good as you want. And then the characteristic file, which is trained on the spoof or no spoof labels.
Okay, I understand. But my question is, if you would like to, if I would like to check if some recording is spoof or not, yes. So do I need an examples of like previous clear recording of this speaker?
I think that's the model that just
So if you have trained on speakers like A and B, so you will not be able to reason about speaker speaking.
actually in the training set we have different the algorithm which were used for the one for the algorithm. So the time on the algorithm on the time speaker.
But it depends.
Just have a couple of questions. The first is about fishing. You mentioned fishing, one of the study slides, number 2, number 3. Could you please go back to that with the word fishing? What does phishing mean?
And I think that we
Just read what is written there. Oh, it's not about phishing. It's about phishing. You have to be sorry about it. I have one more naive question. If you please allow me, if you please go forward to slide number 9. Yeah, what does development mean here?
Development is the name of the petition set.
Just the name of the set,
Yeah.
of the petition,
Of the partition of the
data
data
set.
set. Yeah.
Why development?
It's used for the. Okay, so we have trained for training models, development has to the thing, and then for that we development for hyperparameter units, so we are already the full.
Yeah, so to point to this one, thank you. And then one more, I would like to press the pain point on the cross evaluation. See, to cross evaluate your model against the state of the art.
Actually, there are the results of the state of the art, which was mentioned.
You just take the result from the literature or repeated their experiments using your environment.
There is one moment, one point, because we don't know the exact characteristics of the state of the art. The exact parameters, the exact number of different pairs.
They do not open code the data.
Yeah. And thus we cannot repeat this result by ourselves and need to rely on what we have published.
It's very strange to hear that those guys are accepted to be published without opening their code and data.
They're accepted to publish it on this competition, since they need no access this before.
Okay, thank you very much. And
Any questions? Okay, thank you. Kateryna?
I'm so sorry.
It's
Yeah,
Be
it's
cool.
just setting the kind of one. And second.
okay, please go ahead.
So today I'm excited to present the project on the phenomenon of dehumanization within the context of the ongoing 2022 Russian invasion that I, as well as many prominent scholars, consider to be genocidal in nature. These are the key points. These are not the key points that are probably. So these are the key points that we'll cover. Slides numbers are provided for your convenience for the Q&A session after the main talk. Please be advised that some triggering content and foul language is ahead, so I'm so sorry about that. So why study dehumanization within this particular context? The first reason is obvious. The 2022 Russian invasion of Ukraine is still ongoing, but the inquiries into whether their action constitutes genocide are already being made, and conclusion about the genocidal nature of this war are already being drawn. The second reason is that crucially there are few to zero real-time solutions that can warn about the imminent genocide. So that's obviously a problem. And the third reason is the fact that, to the best of our knowledge, no large-scale representation study was attempted for Ukrainians, within Ukrainians in modern Russian culture, and trajectories with for this image developments were not yet considered. To speak about such a multifaceted problem, we first need to consider broader sociological and historical context. The stories of Tutsis being called cockroaches during the London genocide, the stories of Jews likened poison, vermin, or rats in the Holocaust, and the colonized people that were represented as simian beasts or commodities are all part of the common shared knowledge. And these cases support the long-held common sense belief that dehumanization is in fact a precursor for the extreme violence. Following this belief came realization that dehumanization is also present as a part of the coping mechanisms of the victim of war. By now, you already observed that in wording that Ukrainians use towards Russians. Not only that, dehumanization is actually present in subtler forms in our everyday life, like objectification. And this is seen to be both a cause and the effect of the everyday mistreatment outside the boundaries of atrocities. This change in the emphasis that discovery these subtler forms brought led to new definitions of dehumanization, and in turn invited new operationalization strategies for the purposes of computational analysis. So for the purposes of our research, we have incorporated these newest understandings of dehumanization into our concept of dehumanization for this research. First, that we need to mention that dehumanization is not a binary presence or absence of dehumanization, presence or absence of animus in the descriptions of the target group. It manipulates the whole set of features that we attribute to human adults. The second thing to consider is that we do not always deny features of humanities. We sometimes exaggerate some features of humanities in order to construct more dangerous image of the enemies, to demonize the enemy. On this slide, you see 4 quadrants that are situated along 2 axes. Of course, this is the useful simplification for such a complex coordinate plane. The first axis, denoted as UH, represents manipulation with uniquely human features. So these are the features that separate us from other animals, from non-human life forms. This manipulation manifests as linking to animals, vermin, parasites, etc. It manipulates features like rationality, sensibility, maturity. The other axis, denoted as NH, represents manipulation of human nature features that separate us from the inanimate objects, automata. These are features like emotional responsiveness, warmth, desires. Dehumanization along these axes manifests as liking to instruments, objects, robots, etc. As you see along these axes may lie extreme dehumanization, which is in the lower left corner. So this dehumanization denies both UH features and NH features. And you can see the extreme humanization up top on the right, which actually does not deny but exaggerates all these features. And this type is not actually dehumanization, it's hyperhumanization, and it is reserved for the members of the in group. And I'm really sorry to say, colonized peoples frequently hyperhumanize their colonizers. So this actually takes place as well. Now that we have a general understanding of the issue, I outline the problems that we focus on. The first problem is testing existing lexicographer tools like sentiment lexicons within this particular context and within this particular setup as language, Russian language. The second task is the adapting existing computational techniques to the task that was not yet attempted. This is the task of binary dehumanization classification. While the first problem, findings from the first problem may inform the decisions on using these tools as additional sources for dehumanization signals for analogous tasks, the second problem can be, the results from the second problem can be directly, solutions can be directly built into the systems of anticipatory governance. So those systems that seek to prevent and predict genocide. The third problem is testing novel zero-shot approaches to the same problem of binary dehumanization classification. These are systems that can enhance the scalability, they can introduce reduced bias, and they actually can be used in real-time mode of application. So this type of solution is extremely, potentially extremely effective for the real-time usage and prediction in particular. And the last problem is testing the explanatory potential of existing dehumanization frameworks. So not only this study can pave the way for the representation study of Ukrainians, the finding can also invite further research to pin down the particular dimensions of dehumanization types of dehumanization that are tightly linked to the extreme violence context in particular. To the best of our knowledge, there are no computational works that focus on this particular scope of the extreme violence dehumanization, apart from the simplest lexicon-based approaches. These are two works that we draw our inspiration, the idea for the techniques that we use. So these works helped us define the scope of the instruments that we use. The first work helped us, we draw from that work the ideas for diachronic analysis and the sources of additional traditional dehumanization signal. And from the second work, we drew ideas for our deep learning analysis, our deep learning approach. You may see reported F1 there. This is not the art. We do not treat these results as state of the art because the underlying entity emulation scheme is different, the scope is different, the context is different, not extreme violence, and the language is different. So these results are not directly comparable to ours. Ours will be state of the art. So these are just really for reference. We frame our main objective as creating a system that is able to receive a sentence in Russian and output a label corresponding to the presence or absence of dehumanization towards Ukrainians. Our supplementary but also interesting goal is creating a span level system that can classify not sentence level, but span level, and not just binary classification, but multi-class classification for the type of dehumanization that were listed on that matrix with 4 quadrants. We use both quantitative and qualitative approaches to evaluation. We approached the problem as follows. First, we collected data sets. We collected the data set from Telegram. Then we crowdsourced and labeled training samples for the subsequent experimentations. Then we proceeded to classical machine learning methods, logistic regression and SVM, and tested the enhancements that included those lexicographer tools within this phase. Then we proceeded to our deep learning approach. We followed that with the zero-shot learning approach, testing for the same problem, and then we concluded with testing the explanatory power of dehumanization frameworks during our diachronic analysis. I obviously need to cover the motivation behind the data set selection, and this is based on a number of factors. I'll outline the major ones. First, we choose the social media platform over the traditional news media because social media platform introduces a more diverse data set. It encompasses more perspective, and traditional news media are often edited and formal, while social media platforms posts are often unfiltered and spontaneous, as you might have observed. So while choosing a particular social media platform, we considered the algorithmic contamination, which is the extent to which the algorithm, safety algorithms and monetization strategies influence the user's content. Telegram has notoriously relaxed community norms, and it has no algorithmic dissemination. The next factor that we considered is the accessibility of retrieval. Given the scale of our data set, we had to make sure that our instruments are reliable, they're accessible, and they will allow us to download all this massive data set without interruptions. Telegram provides that. And last but not the least, actually a decisive motivation for us was the fact that Telegram is a primary political news source for Russians, both with being the main messenger for Russian, according to the Reuters media report for 2022. Overall, we collected full channel histories to date for 299 Telegram channels that are public and that are most popular in terms of their audience, according to Datasets, which is a popular crowdsourced measurement platform for Telegram. You see some examples of the posts from our data set. On the left, the example that I marked as simple includes the we have hypothesized that this will be a simple case for any detection system to capture the dehumanization signal, because dehumanization is embedded directly into the target group label. So we hypothesized that any system will just have no problem to memorize these terms without even a broader generalization. On the right, you see a more challenging case. Here, dehumanization is not even contained within a single sentence. And in the middle, you see the middle ground. So this is the post that is situated with dehumanization of different types and shapes, which is not in common for our data set. So the annotation project that we started to collect data for this project, we undertook a comprehensive annotation project. During annotation project 1, during 2 iterations, we collected 4,129 sentences, that is samples, labeled for presence or absence of dehumanization, along with some supporting labels. During the second project, we annotated dehumanization by label within 478 sentences that were labeled as dehumanizing during the annotation project 1. So there's a continuity between all these projects. And during the third project, we collected annotations for almost 500 sentences. These were descriptive labels for agency, experience, effect, etc. We used We used the Cohen's-Kappa coefficient for iterator agreement. No. We used Cohen's-Kappa for our iterator agreement score. We used 20% overlap between each pair of annotators for the whole data set in order to establish how can we rely on the outcome of this annotation project. So the scores for annotation project 1 and annotation project 2 were high, and for the annotation project 3 score was not sufficient. The coefficient was not sufficient, and we did not proceed with using the outputs of the annotation project 2 in our work. The distribution of labels for the annotation project 1 for first and second iteration is as follows. In red, you see the positive class. In blue, you see negative class. The difference between these iterations is that during the second iteration, we used fully automated approach for sample preselection that was in part based on the output of the iteration 1, the supporting labels for mention and for sentiment. So we trained additional models for us to help to automatically preselect these samples. The approach during iteration 1 was semi-manual. I'll be happy to share the details of our approach during the Q&A session. We proceed to the next annotation project. This is the distribution of the types of dehumanization. The proportion of the type demonizing rhetoric is the largest among all 4 types, 3 types of dehumanization, actually. The fourth one is the Ukrainian attack. This is a supporting attack, so that we did not consider that. I'm so sorry, I can't put the power language. These are the samples from annotated project 2. These are the samples of all the types of dehumanization with the Ukrainian attack that I mentioned before. I partly hope that you did not read that in full. We started our experiments with classic machine learning. First, to establish the baseline performance, but not less important was the leveraging their explainability. So we combine the insights from this analysis with the enhancements of the following four types. First, we tested the lexicography tools. As I mentioned before, these were lexicons, 6 lexicons for sentiment and connotation. Scores from these lexicons did not show any statistically significant correlation with the dehumanization labels, so we did not proceed with this enhancements further. Next, we hypothesized that the idea that some collocation may retain dehumanization signal better than other collocations or full texts. So we tested 4 types of collocations, and this idea really panned out. We used that further. Round-trip translation. This is the trick of translating Russian text into English and back, with the hopes that metaphorical content will corrupt the perplexity score as a result in the resulting text translated back to Russian. We tested these scores for round-trip translation, but the perplexity changed. They did not show statistically significant correlation with the dehumanization label, so we did not proceed with that. And the last one is augmentation of negative class. This was really useful. We upsampled negative class with simply replacing non-dehumanizing group labels. These are results for the classical machine learning experiments. You see that SVM with enhancements show the most promising results. Our positive analysis showed that these models perform poorly on subtle metaphors, which you can see by the fact that models are conservative, precision is higher than the recall. They sometimes misclassify samples with correlated imagery, which makes sense because they often co-occur in our data set. And they showed poor performance on particular types of texts. I'll briefly mention that we, for illustrative purposes, we tracked the performance on the so-called positive and negative test sets, which are the test sets, respectively. Positive is the one that might contain dehumanization within target labels like Ukrainian that you saw before, and negative one is the test that does not contain dehumanization in target labels, so more to the more challenging parts, to the subtle metaphors. You see that our augmentations, our enhancements were useful for both of these types, so we would recommend experimenting with them further in order to capture better subtle metaphors in particular. We turn to our deep learning approach. Our deep learning approach, we tested the attention model for span-based joint entity and relation extraction, which is called SPERT. SPERT adopts span-based approach, span being the sequence of tokens, where each span is treated as a potential entity, and between those entities, each two entities relations can exist. We were especially interested in the context-sensitive embeddings are capable of expressing complex semantic and syntactic patterns useful for our task. So, like disambiguate homonyms and so on and so forth. To map the output of span-based multi-class classification to sentence levels binary classification, our main task, we use simple indicator function and assigned 1 if any entities were found in a sentence of different entities, and 0 otherwise. The results are promising. The results are best overall. The system just letting down. So the results are really promising. These are the best results so far, and crucially, precision and recall is better balanced, almost perfectly balanced, both for positive set and negative set. And the gap between positive and negative test set is far smaller than previously. Qualitatively, we estimated that they perform better on subtle metaphors. They can be more. Next, we turn to our zero-shot learning approach. Since ChatGPT 4 at the present moment is not currently available, publicly available, we used 3.5 Turbo through the chat completion API endpoint. We relied on the recommendations from the OpenAI team, as well as on the empirical evidence of developers in the community to construct 80 variants of prompts for our task. The output mode prompt was constant, and role definition and thinking mode were variable. I'll be happy to share examples from that during the Q&A session. Crucially, the performance in the negative test that was the best when no role, no definition, almost no instructions at all were provided, which actually aligns with our expectation that inherent safety instructions for the model make the model behave extra cautious. So during the qualitative analysis, we saw that it actually misclassified samples with just derogation and negative sentiment. So it is being highly triggered by the set of content. Performance is promising, but still not as good as performance for the first model. This is the final comparison for the models. So we chose SPERT, the mapping function, as our best model, and proceeded to diachronic analysis, which I'll cover really brief, and then during Q&A session I'll be happy to provide more details. So this is the story that we can see in the in our data set. The lines are color-coded respectively. They correspond to these 4 quadrants on the left. Extreme dehumanization behaves. This is the most stable trend among those 3. And dehumanization that manipulates just one dimension, they follow the same pattern. They, same as each other. 2 lines, we added 2 lines, reference lines. The first blue line is the data publication of the Putin essay on the historical community of Russians and Ukrainians. And the red line is the start of 2022 Russian invasion. So we are not equipped to draw conclusions, obviously causal conclusions, but some conclusions can be investigated further. You see that this essay, it actually claimed that Ukrainian statehood itself ultimately depends on Moscow consent. So we can actually treat it like the announcements. I could argue that. So during this stage, we partially confirmed that dehumanization is definitely important for the preparatory steps. So the 4th stage of genocide offered by the Gregory Stanton, who is prominent genocide researcher. And also we can see that dehumanization is not a singular phenomenon. Different types of dehumanization behave differently. So for our 4 problems, here are 4 conclusions. First, dehumanization is not a singular phenomenon. We saw that. Transformer-based approach is the best so far, but zero-shot learning approach trails closely behind. And this is really promising because it opens a possibility of broader and usage without waiting for people to collect data and annotate samples. And the last conclusion that we draw is that lexicons for Russians are not helpful for analogous tasks. Maybe better lexicons would do the trick. We recommend for future work experimenting with contextual representations, use better techniques for automatic preselection to better mirror the real distribution of classes, testing the solution on the data set from different social media environments and news media, and using lexicons of better quality. The reviewers' notes encompassed that partly. They suggest working regarding the data sets. We actually already planned that work, publishing data sets and work on that separately. And of course, using contextual embeddings and conducting a computational complexity analysis, which is also a valid future work avenue. Thank you so much for your attention. I'm so sorry for being so late. To share more.
Surprisingly, I did have one question. I'm a bit curious about the reliability of your crowdsourcing approach for data set preparation, labeling.
You mean crowd workers?
Yeah, crowd workers. I'm interested who were the subjects for this crowdsourcing work.
Yeah, so we disseminated the invitation to participate in this project over the community. And as the online stated, 14 people took the participating in this project. For the first project, we used criteria that have been native in Russian and Ukrainian, being Ukrainian citizens, do not have any connections to Russian state. So, and be of 18 years old and older. So no additional restrictions towards the crowd workers are represented. But this 20% overlap guarantees an estimation of this incremental agreements guaranteed that those people did not just guess each other's annotations. So this Kohen-Kappa coefficient is used specifically to ensure that they are united by their estimation. There is no other way to annotate this kind of data set. But we introduced some additional restrictions for the third data set. So we required sociological or psychological education for people who participate in that.
I'm so curious if it was possible to avoid bias in the first two statements.
We tried really hard to come up with an ideal airtight solution, but unfortunately we chose the best out of the worst, because we could not obviously use Russian speakers, not Ukrainians. We could not use people from Russia because we would not, we would never be sure of the absence of bias.
It would be biased.
Yes.
And I would rather go for some faraway foreigners.
Yes, but they will not be culturally aware enough to understand that, for example, Burovova is not a derogatory term for us, but just the technique.
I'm not arguing the task was.
Definitely, some bias definitely was introduced. This is the irreducible amount of bias that.
So, my intention while asking was to find out if you were aware of it.
Sure, we covered this topic in our work. So we list it as a limitation of our work because it's,
I was also a little bit surprised that you constrained yourself by single sentence fragments.
That also has a motivation behind it. We consider the trade-off between using too broad contexts like the whole post and too narrow contexts like particular span. During the preparatory work, we randomly estimated different types, different shapes, as I already mentioned, of the post and summarization within those posts, and we concluded that sentence contains the finished thought that is not inherently compromised by other thoughts. So it's not, that does not contradict within this sentence particular granularity level. So yes, different types of dehumanization can be present, but they are aligned in general semantically.
Did I understand correctly that one sentence was somehow extracted from our post.
No, the post was tokenized into sentences, and we consider it.
So you said all the tokens.
Yes, yeah, all.
Thank you.
But actually, I wanted to ask about the question of the grammar of Telegram posts differs
Not
from,
ideal.
yeah, so therefore there may be no punctuation marks, no uppercase letters, and how
No, we developed.
how do you determine when
Yeah, this is a definitely challenge for tokenizer. In particular, as I already mentioned, for the classical machine learning approach, some texts are just digest. So this happens then, this happens then, etc., etc. So these texts aren't classified often because they're tokenized just by punctuation marks initially and listed as a downside of our approach. But it's computationally invisible to use more sophisticated tokenizers, sensitive tokenizers. So this is a approach that did bring some non-sentence pieces in our work, non-sentence samples, but we estimate the performance quality to build them separately. So yes, this problem exists, but it's not as common. I assure you, people really use those. Yeah, not common though, but those. Yeah.
We know that there are such a phenomenon as photo farms.
Yes.
So, have you detected any signs of deliberate intrusion or yeah, framing the social attitude by manipulating?
Yes, this is actually a really excellent question. Because in the beginning we considered collecting not only the posts but some of the comments in comment section, if those exist, if those are allowed for this particular channel. And we again qualitatively estimated. We saw that a lot of bots are there. So we feel that that input cannot be attributed to human. So it's not a human content. So we stick with the posts because posts have authors. So those channels are sometimes anonymous, but from people. We do not perform network analysis, but this is an interesting avenue of research. Our dataset, though, contains the information about posts being forwarded, and so that information may be used for evaluation how those are disseminated. So when we prepare our dataset work, we will definitely include that.
Or if you pay attention to repeated, I mean, without being forwarded, some messages could have been disseminated by a group of real people, say, or maybe one person.
We try.
Person managing several channels. Just again, it's artificial influence of.
We tried using unsupervised approaches. We did not include that into our work because it was excessive enough. But we used different techniques for clusterization to try to uncover some patterns, maybe even identical or similar texts. But that unfortunately did not give us any coherent results, so we did not include that. And we were not able to separate those activities, coordinated activity.
Sometimes this Telegram channels the methods use emojis, and these emojis are usually quite instructive because they show some animals.
Yes, and
Yeah, we use
Yes, yes, because sometimes the humanization is using images as a hint, like big face.
Yeah, how you do deposit into your pipeline?
It was actually labeled with as part of the span. So in these span labels, in the span based first approach, we use them as the part of the label.
Yes. Can you show this plot with the attitude over time?
Sure.
I mean, when you estimate the work, you can also estimate the conclusions and predictions. So, as I understand this, the worst possible is the orange line.
Yeah, this is the worst. You
Yeah,
can say that.
and green line, it's like they're strong. We want to fight with them or something like this.
No, they do one thing. They're Nazis, they're demons, etc. And the green one is their animals. If I'm not mistaken.
Your diploma, I believe it's.
Oh, yeah, maybe it's other one. So, what is already to the colors?
Can you explain this piece in 2019?
I would love to, and I really tried. As I mentioned, I'm not equipped for the causal analysis of all this, but this peak is around the time, if I'm not mistaken, of the election process. Yeah, so I did not add that as a reference line because we cannot make counterfactual statements regarding what could have happened. We though see that they behave, they are synchronous basically, and our idea is that these types of partial dehumanization are motivated by particular political agendas. So these are things that are pushed over people. While the yellow one, which is considered by neuroimaging studies were conducted to confirm that this so-called low dehumanization is can be tied to visceral feeling of the disgust. So neuroimaging studies were conducted to confirm that when people dehumanize with this pattern, they show patterns in their brains that they are feeling extreme disgust. So this low trend.
Can I add this? It's interesting to see those 2019 related to elections in Ukraine, to see how those split between two main political candidates for the president.
Probably election in Russia in Ukraine.
I mean, so because they can use it to support one candidate and against another.
Because
This is definitely a great election that is
Ukraine, but they can involve Ukrainians by supporting because there was tensions to support one against another.
if what reports are in the data sets. An interesting observation is sort of peaks in green and blue, and the yellow curve goes down at the same time.
yes, that I
Which is not very coordinated, coordinated committee at this very time.
that is
By
really-
the end of the presidential election, when the situation I mean, try to turn it to words.
You need to promote this work to social science and political science students, so they can continue using it later to the president.
Yeah, it's not simple in the possible.
My question, what is why exit here?
these are the average number of samples per time step.
And is it weighted?
This is actually a time step for 3 months. We use equal allocation for these time steps.
Can you test it?
That's the fact that basically frequency of occurrence.
It was one, you have this event here, class, and you never use it, yeah?
Yeah, this is not a humanization, this is not a humanization, this is humanization, this is the subject of different set of studies, for example, colonial studies, well, Russians do not hyperhumanize us, but if they would hyperhumanize us.
But can they just include neutral statements here, or for example, sometimes they admire by Ukrainian forces. It's actually happens sometimes. So can we include this? But because right now it's like you have something and you don't.
We actually cannot, because humanization is not a just negative sentiment. So this is not an opposite of admiration. Humanization is a particular distinct phenomena, and hyperhumanization again is depicting. It would like depicting Ukrainians as superheroes, as really supernaturally clever people. So it occurs, for example, if we analyze, I just can name just one. For example, when English people, based on their accents, sometimes just feel like they're more clever. So this is well, this is not scientific. My example. Yes, it's yeah.
So this is why I was smarter in the final decision to drop it here. It really requires to include a sort of emotional analysis, like sarcastic, like.
Yeah, those actually emotional.
Only maybe may look like an adoration, like it's ridiculous, but the general mood of also be very much sarcastic.
Sarcasm is notorious by its
This is why there was not decision to drop the master. We'll have to do have more things to do in the next level.
Okay, what about Slaughter? Do you have any close or similar works in English, for example?
No, we have not. We have just one reference value. That is not a state of the art, because we cannot definitely compare them. Absolutely cannot, because the underlying entity scheme is different, the context. And I'm showing, I'm not showing. So this second work towards the form-based NLP for extracting indicative forms engagement investigated different types of moral engagement, including dehumanization, where dehumanization was just one of 6 attributes. And besides those attributes, there were entities and relations to consider. And one result was, as you see on the slide, we cannot directly compare that, and no binary classification was present. So this is our problem.
It's not does not meet for cross variation because there's a different set.
There is not really to compare them to the best of our knowledge.
So can't do the humanization of this thought of the pieces.
I would argue that the results in this study cannot be compared to ours.
This is a different story.
Yes, I used to
State of the art is the achievement which is on top of the in the field which is top. And in other contexts, you cannot compare to that, and this is the means that this source is not does not be cross variation there.
This is why I actually wanted that nevertheless I did not compare. So this is
This temporal dependence, temporal rest. Does it mean that all program channels you analyze except for at least
5 to 6 years?
This is a great question. Actually, as I mentioned before, I would be happy to show you some more descriptive statistics on one data set. So we see that the whole data set is extremely biased towards the more recent time. This is the quantity of costs over time. So first, data set is balanced in this manner. And regarding the distribution of cost, we see that some channels cost highly frequently. So this is quantity of cost per day here. So it's yes, it matters for temporal analysis, but for the overall trading, we cannot infer, we cannot take into account how different channels appeared on the scene. So no, we collect this entire post history. That means that some channels existed in the time step 1, and others were added as they went along. So yes, there is a balance regarding others. Temporally.
Could you create the internet data sets which exist more before that? It starts from about what it will say,
We considered Twitter, but the data on Twitter isn't accessible right now, or I mean accessible, but for a lot of money. And besides, we took into account that already there exists the data set that is called Vaynaswap. So this is data set of posts collected from Twitter and, if I'm not mistaken, Contact. So we considered that these data sets can be used to test our approach cross domain.
Please took my question months. Can you please revert to slide 23? Because I think this is the most interesting result. 25.
Yeah. Is this the one?
Yes. So again, can you please somehow interpret this peaks in the president election?
I would love to. Personally, me, I can infer, without making some really loud claims, that these different types of dehumanization, they push different narratives that can actually support different voter groups. For example, one narrative is that we are Nazis, we are war machines, we prepared to crush them, and those could be for President Russia. And the narrative that we're clowns, we're animals, we're like absolutely useless and we have no power, that would be the second candidate. That's
like racing this curves.
Yeah.
But I am asking about dropping.
Oh yeah, drop is the most interesting part. The idea can be that they just shifted the time frame of what they're already planning. So they saw what's going on and they hoped that they would not have to intervene, probably maybe with war machine, and they would destroy the states from inside, but that did not pan out, fortunately. So, but beyond that, I cannot honestly.
So we can like hold the situation as all things go like plan.
As everything.
And yes, we can see the next race in for the like call.
Yeah.
And the interesting thing here is that the red line is like about 0 years.
Red is the thing.
All the time.
Yeah, red is all the time personal hyperhumanization.
This is like, yes, for me, that's the most interesting result. And second question is like, of course, overall, it is very comprehensive work, obviously, but do it have potential to be for the non-variable, so to predict, to anticipate, detect some new situations?
Yes,
And you got how? I like describe my thing. So you rely on some kind of specific words, like UKUR, and but how can you predict which words should be taken into account, into consideration, into research, for finding like new such kind of situation?
Yes, so this work can actually be expanded first to any minority that is affected by Russians. Just because our approach includes the vector space modeling for selecting the nearest neighbors for the sign by the sign difference to the most common target group labels. So, for example, when you consider some minority in Russia, you always know what are the non-derogatory and derogatory like first 5 names that they use. Then we use the training on the whole data set to find the nearest neighbors to those names to include as our target group labels. We did it here as well, so we did not rely only on the UKUR and POC sequences. We expanded that, and that actually can be transferable to other nationalities.
I was not so clear,
Maybe.
It is like more or less obvious how to analyze the situation that was in the past.
It's still,
But how we can now understand which conflicts are ongoing and will be in the nearest time planned.
yeah,
How we can like detect it? We don't know which countries to take attention to them. We don't know which particular words could be like offensive or something like this. Absolutely not. So if we are Ukrainian, again, one more item. If we are Ukrainians, we understand more or less which words could be like offensive, could be of interest, and so on, and from which point we should start our like research. But how we can help with these methods for predicting like a situation, such situation, or another other kind of situations in the future. And one more thing, like one more complicated, that now we understand in which like direction we should think about this work. But maybe in other like place on our globe, it would be like a new kind of conflict, new kind of war, which is not like characterized with the way we are thinking. So could be like somehow transfer your result to predict like absolutely unknown situation.
Yes, this work is definitely not meant to be a standalone predictive algorithm. This work comes into place when the risk is already being established by, for example, political analysts, by some historical background of tensions between the countries. Actually, some solutions for predictive analysis already exist, but they are manual. So I know about one example of just moderators monitoring for certain cultural things between two but this method can be built as a stage, but it's a later stage. So you are definitely right. The cultural landscape of civilization will differ in any case. This is absolutely not universal, so we have to build into our system the knowledge of people who are within the culture, as well as this was the motivation for choosing Ukrainians over other people. But within a particular setting, within a particular
extension, the landscape is stable. So the cycle of humanizing rhetoric is pretty stable, as we've seen with Rwanda and Holocaust. So yes, it can be transferable, but as a stage, not as a standalone.
No, and something wrong. Those hypotheses,
Yes.
they happen like pre-research for finding specific work so on.
Yes, but with the zero-shot approach, we actually have a first reduced bias, so we do not need those annotators. And real-time model application is already mentioned. It's not the best result, but it is really promising result because we can use those models as a even first stage of analyzing, because it requires only our, for example, definition of what is implementation without any cultural specifics. So I really hope, and it was my motivation, that the systems for this preventative analysis would incorporate zero-shot approach. Thank you.
One last question. What's your plan for publishing this?
I actually plan to speak with my supervisor. We already touched upon that. To form the guideline, to form the path to publish the data set, so that other people could experiment with that, and of course, describing it.
Thank you so much.